Step number 1, find the product. And the product we call A times C, or if you're a word person, it's the first number times the last number. And a lot of people go, well, yesterday was just the last number. Not really. It's just the very first number in the question yesterday was 1. So 1 times the last was always equal to the last. So we were doing this, you just didn't know it in these terms. So we call the product times A times C, or if you like it in words, the first times the last. Find the pair of factors that add or subtract to give the sum. Find the pair, that should be not plural, find the pair of factors that add or subtract to give the sum. And the sum is what we call B. If you like words, it's the coefficient of x or the middle number, okay? Whichever way your brain likes it best. Call it B, or it's the coefficient of x, or it's the middle number. Step number 3, copy the first term. Leave a space. Copy the last term. Copy the first term, leave a space, copy the last term. Unsimplify, or sometimes I'll use the word split. Unsimplify or split the middle term into those factors. Unsimplify or split the middle term into those factors. Group the first 2 terms and the last 2 terms. Group the first 2 terms and the last 2 terms. Group the first 2 terms and the last 2 terms. Some people like to name the terms 1 through 4, so you're grouping 1 and 2 and 3 and 4. Okay, because you'll always have 4 terms in this spot. So group 1 and 2, group 3 and 4. And common factor each group. And common factor each group. And I'm going to put a red star. There's a built-in check. The built-in check, I call it the matching binomial. It's whatever makes sense in your head. So it's that step, once you've common factored, is what's left in each group has to match. So I call it the matching binomial. If that makes no sense to you, write something else. The matching binomial. Sometimes I call it the twinsies, because they're the same. Write the answer as 2 binomials. Whenever I write 2 binomials like that, it looks like butt cheeks to me. It always makes me giggle. Come on, tell me you didn't see that before. Now you will. The first one is what I call that matching binomial. The second one is the 2 common factors. Again, yeah, it's a lot of steps at the beginning. The more you do, the easier it becomes. By the time you get to grade 12, you'll be able to do these questions in about 10 seconds, because you will have practiced 100 of them. So go to paper. We call this type ax squared plus bx plus c. And I like to highlight, it's this a that makes it different from yesterday. And you can do yesterday's type like this. It just means you're doing 3 extra steps you don't need to do. But once your brain learns this, if it wants to do this for everything, that's fine. You guys are so quiet today. I don't know what to make of that. Okay, keep those steps right beside you because you're going to need to refer back to them until you know this off by heart. Step number 1 is the product, and it's the first times the last. So in this case, it's 6. The sum we're looking for is the middle number or the b value, which in this case is 7. Already, a lot of you could see without even writing them down, it's got to be 1 and 6 is the only combination that's going to equal 7. Okay, so I'm just going to make a note. This was step 1, and this was step 2. Step 3, I'm going back to the question. I'm going to write down the first term. I'm going to leave a space, and I'm going to write down the last term. Then what I'm doing is I'm just unsimplifying, or I'm splitting that 7x into the sum, which in this case is plus 1x plus 6x. And if you need to put that 1 to see where it's coming from, you can do that. We just typically don't write it. But 1 plus 6 is what gave me 7. The order doesn't matter. I could have put 6x plus 1x. It doesn't matter the order. It will give you the same answer in the end. Step number 4, I'm going to group the first 2 terms and the last 2 terms, or terms 1 and 2, and terms 3 and 4. Visual people at the beginning, sometimes it's good to cover because your brain gets overwhelmed if it sees a lot. So just look at this as a common factoring question. Common factoring, we find out what's the same. What's the same between 2x squared and x? It's got to be x. Bless you. Then what we're doing is dividing each term by x. And if you need to write it, write it. So 2x squared divided by x is 2x. And x divided by x is plus 1. Okay, the second group, what's common between 6x and 3 is 3. When we divide each by 3, we get 2x plus 1. This is the check. If these are exactly the same, and there's no kind of the same in math, they're either exactly the same or they're not. If they are exactly the same, you have done everything right up to this step. If they are all, if that was a 2x minus 1, if it was a minus x plus 2, if they're different at all, you've done something wrong. That's what I like about this factoring, is you always have a check right before the last answer. Step number 5, answer is 2 binomials. The first binomial is the common one, or the matching one. And x plus 3. We just take the 2 common factors, slap them together for the second one. Could we check it? Sure. How do we check any of these questions? Foil it. This has to be your answer. If this isn't your answer, you've done something wrong. Again, I know at the beginning it's a lot of steps, but the nice thing is they're going to be the same every single time, and there's no exceptions. These are always going to be the same 5 steps. Okay, let's do a whole bunch together to practice. This is smart people in math. Not everyone can do this kind of stuff. If your parents took pre-cal, they'll look at it and say, yeah, I kind of remember that. And then when you show them, you'll seem so smart. Step number 1 is product. Product is the first times the last, which in this case is 5 times 1, so it's 5. You don't need to write the 5 times 1. If you just want to put 5, that's fine. I'm just showing you all the steps for the first couple. Step number 2, we're looking for the middle number, which is 6. What are the only pairs of terms that are going to multiply to give us 5, add or subtract to give us 6? 1 and 5 is the only combination for this one. 1 plus 5, 5 plus 1, I don't care about the order, it's 1 and 5. Step number 3, keep the first term, leave a space, keep the last term. What we're doing mathematically is just splitting up that 6x into 1x plus 5x, or plus 5x plus 1x. Doesn't matter the order, we'll give you the same in the end. Visual people sometimes like to see that arrows or those little lines to show the splitting, so if your brain needs that, write that in. So all we're doing is we're unsimplifying because the last step of multiplying would have been simplifying. Group the first two, group the last two, or groups 1 and 2 and 3 and 4. If you don't need those boxes, you don't need to write them. If your brain's like, whoa, now that's a lot, just look at the first two. What's common between 5x squared and x? X. Okay, so factor out the common factor means we're dividing each of these by x. 5x squared divided by x. X divided by x. Exactly the same with the last group. 5x plus 1. What's the only thing that 5x plus 1 have in common? And if your gut is saying nothing, then that's a 1. What's the only thing I can divide both 5x and 1 by? 1. So this just has a common factor of 1. Well, if we divide them each by 1, they're not going to change, so 5x plus 1. Check. What's our built-in check on this step? Are they both the same? If they're not, you got to go back to the drawing board. If they're both the same, we are good to go. The answer comes from the matching binomial, and the second binomial comes from x plus 1. The two common factors just smushed together. Show me your thumb so far, and if you're on the side, I'm A-okay with that at this point. Okay, good. Number 3. (2x squared minus 5x minus 3). Step number 1 is the product, and the product is first times the last. In this case, it's -6. Sum we're looking for is -5. If the product is negative, what does that tell you about the two values we're going to use for the s? One has to be positive and one has to be negative. So for some visual people, it's helpful to put in the signs to remind yourself, if I have a -6, it's got to be a positive and a negative. If that does nothing for you, then don't write that down. I got 1 and 6, and I got 2 and 3. And again, this is like when we did the 5-6 combo is often hard. So the reason it's helpful to put this is because it's going to stop you from picking -2, -3. Why can't I pick -2, -3 if that gives me -5 when I add them? Because -2 times -3 is +6. So putting these signs sometimes is helpful. It's not 2 and 3. What's the other combination that's going to give us -5? -6 and +1. So it's got to be +1 minus 6. Again, I'm just going to repeat. -2, -3 definitely gives us the sum. The problem is when you multiply -2 by -3, you're going to get +6. And if the product is negative, it tells you the signs have to be opposite here. Keep the first term. Keep the last term. Unsimplify that -5x to get +1x minus 6x. And again, the order doesn't matter. I could have put -6x plus 1x. Common factor the first two. I heard x. Confirm. Okay. Divide them each by x. Offer of 2x plus 1. Common factor of -6x minus 3. Offer of -3. Confirm. Okay. Divide them each by -3. I had a few faces went, -3 or 3, -3 or 3. If you had just taken out 3, which is a common factor, what would have happened here? We would have had -2x minus 1. And now what would have happened? Wouldn't have been the same. So if your gut said 3, that's fine. You would have carried through with the 3. You would have had an unmatching binomial, which will tell you to go back and take out the negative 3. We got the matchy-matchy, so we're good to go. Answer has to be the matching binomial for the first one. And the second one comes from? The common factors just slapped together. Okay, number 4. 4x squared plus 8x plus 3. You're going to do the step, then I'm going to do it right after you. Then you're going to do the next step, then I'll do it right after you. So step number 1, product. Product is 12. If you want to show that 4 times 3, great. You don't need to if you don't have to see it. You do step number 2. The only combination that's going to give us 8 will be 2 plus 6, or 6 plus 2. I don't care the order. You do step number 3. There's step number 3 is just splitting up that 8x. And again, I don't care the order. You could have 6x first and 2x after. You do step number 4. There's the 2 common factoring. How do I know I have it right? Because I have those matching binomials. You do step 5. Ooh, tricky. What did I do there in the last step? Switch the order. Does it matter? No. 3 times 4, 4 times 3, are they both equal to 12? Yeah. So sometimes the book will have them backwards to you, and that's okay, as long as you have the same terms in each bracket. Show me your thumb now. Are we getting better? Good. Are you ready to try one with a friend? Or someone who at least looks friendly? Okay, give you a couple minutes. Try with a friend, then we'll talk. Yeah. I heard minus 60. Yeah, okay, so product minus 60. Wow. Some we're looking for? This is where your brain's got to work. Okay, 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, 7, 8, 9. Okay, 60 is the largest we're going to ask you without a calculator. So you need to know all the factors at least up to 60. There's only one combination that's going to give us 11. If this is negative, what do we know about the signs here? One has to be positive and one has to be negative. I heard 15 and 4. Why is it positive 15 minus 4 and not minus 15 positive 4? So why is the 15 the positive 1 and the 4 the negative 1? Because it would be negative 11 if we switch them. Keep the first term. Keep the last term. Now, it'll matter which way you put the order here, but the answer will be the same in the end. I'm going to put the 15 first. Okay, if you put them the other way, it's fine. You'll get the same answer in the end. You're just common factoring will be different. Okay, so this is where you said you're stuck. Why? So what threw you off in this first part? Yep, so you're taking out what's the same out front and then dividing. What's the same between 10 and 15? What's the same between 10 and 15 first? 5. What's the same between x squared and x? X. (10x squared) divided by 5x. 15x divided by 5x. What's common between negative 4x and negative 6? And do we want to take out a positive 2 or a minus 2? How do we know minus 2? Because we know the number here has to be 3. And what's the only way to turn a negative 6 into 3 is to divide by a negative 2. Negative 4x divided by negative 2. Negative 6 divided by negative 2. Answer, 2x plus 3 times 5x minus 2. So I'm just curious, what part did your brain go, whoa, I'm stuck? Was it the common factor of the 5x? Yeah. Okay. Questions with that? Backwards, that's fine. Still the same process. You'll have the same answers in the end. Try number 6. Give you a couple of minutes. Half mark off. Questions on any of the steps? Brock.
On a quiz test, will we be asked to leave the 2x plus 1?
So on a test or a quiz, are you ever allowed to leave x times x? How would we expect you to give x times x? So same thing. So it'd be a half mark off if you didn't see that these were the same. Who got it, we'll say without that last step, but who got down to the x plus 2x plus, good. Good. Questions? Anything you're not sure where it's coming from? Okay, let's try the last one all by yourselves. Say goodbye to your friend. Goodbye, friend. Here's the first 3 steps. Remember, you can switch these. That's A-okay if you switch your minus 4x plus 3. Questions on just the first 3 steps? Any questions on the first 3 steps? Okay, finish it off. Because we need a minus 1. And because of the minus 12, we know the signs have to be opposite. The only way to get minus 1 is minus 4 plus 3. finish it off. Can't you just have? So where did your brain go with this? What did you put down?
Oh, I was just gonna reverse.
That's fine. Yeah, so if you have these switched, it's fine. You can have -4 plus 3. That's fine.
Oh, okay.
That's fine. So if you had them switched, your factoring here will be different, which is fine. You still have a matching binomial.